Okay, today we're going to have a look at a HSC question on the future value of an investment involving series and sequences in financial mathematics. So we've got Peter retires with a lump sum of $100,000. The money is invested in a fund which pays interest each month at a rate of 6% per annum, and Peter receives a fixed monthly payment of $M from the fund. Thus, the amount left in the fund after the first monthly repayment is $100,500 minus N. Find a formula for the amount A, N, left in the fund after N monthly repayments. So A0 is going to be our $100,000. And we've got to try and develop some sort of recurrence relationship that is representing this investment which we're also taking out money. Now, it does say it's 6% per annum, but the interest is calculated each month. So it's going to be 6 divided by 12, which is 6% divided by 12, which is 0.005. So if we use our compound interest formula, we're going to get, right, well, after the end of the first month, the $100,000 is going to experience interest, and then we're minusing M. That's our monthly repayment. Now, this is 100,000 times by 1.005, 1 plus 0.005 times M. Right, let's have a go at A2. Our A2 is going to be 100,000 times by 1.005 minus M. Now, this amount is experiencing a growth. That is how much is in the bank account, and it's experiencing a 5% growth, and then we're taking out my monthly repayment again. Now let's expand that, because expanding it is going to help us when we're trying to convince the marker that this series is actually working n times. Right. Let's try A3 now. Now we usually only do 3 applications of a recurrence relationship before we become more generalized. And these can get quite long, these questions, but they are definitely doable. So we're now writing out how much is in the bank account at the moment. That's how much money is in the bank account, and it's experiencing 5% interest. And then we're taking out my monthly repayment. Right. Let's have a go, see if we can recognize a pattern. I've got 100,000. I might expand this actually, 100,000. Let's see if there is a pattern. Times by 1.005 cubed minus 1.005 squared M minus 1.005 M minus M. Now let's try and develop some sort of generalized recurrence relationship. Now it's clear to me that this and this are the same number, so the power is always going to be the value of n. Right. Now something that's common between all of these is an m, so let's take out a factor of minus m. Now if we take out a factor of minus m from here, well, that's going to be 1 plus 1.005 plus 1.005 squared plus ... plus, and we're thinking, okay, what's going to go here? Now, we're looking for the value of the investment after n months, right? And that means there's going to be n terms in this sequence, which actually means this power here is going to be to the power of n minus 1. And that's because the value of n, the power of n here, is 0, yeah? We're going to have times by 1.005 to the power of 0. Alright, we're really close because this here is a geometric sequence. So we can say this is 100,000 times by 1.005 n minus m outside of the sum of a geometric sequence. The formula, if we want to write it here, is a outside of r minus 1 over r minus 1. Now a is the first term, which is 1, so we know that the common ratio is 1.005 to the n minus 1 over, well, 1.005 minus 1 is 0.005. Alright, and that's good enough for our formula. We've developed a formula now. Okay, if you're watching along, I want you just to pause it here, maybe screenshot that question there, because we're going to have a go at question 2. We want to know, Peter chooses a value of m, so there'll be nothing left in the fund at the end of the 12th year, which is 144 repayments. So, in other words, we are setting the value of n to be 144, and the value of an to be 0. So 0 equals 100,000 times by 1.005 to the n minus m outside of, now it's 144 repayments. Right, and we're just going to solve that equation, so let's have a go. Now, if we go move everything to the other side, I reckon we have the ability, we're going to move this to the other side and times 100,000 by 0.005. Let's do that all in one go because we're really smart. 005, 144 minus 1 equals, now 100,000 times 0.005 is 500, so 500 times by, and I think I've been a bit silly and there should be an m right here, and times 500 times 1.005, and I've been really silly again. We've set n to be 144, so we're going to make that 144. So m simply is going to be 500 times 1.005 to the 144 over 1.005 to the 144 minus 1. Type that into your calculator, you get the monthly repayment, which would be very hard to live on, but $975.85. Okay, thanks for watching.